This segment in the Soil Health, a Montana Perspective video series will discuss one of the tools that agricultural producers can use to improve soil health. This tool is crop rotation. A conservation crop rotation increases crop diversity by growing different types of crops in a planned cropping sequence. There are 4 types of crops: cool season grasses, for example, small grains; cool season broadleaves, for example, peas and flax; warm season grasses, for example, corn and millet; and warm season broadleaves, for example, soybeans and sunflowers. For a successful diverse rotation, it is important to have at least 2 different crop types in a field before you come back to your original crop. For example, if you planted wheat, you might want to plant corn and peas in the subsequent years before you went back into wheat. In this rotation, you would have 3 crop types represented. This increased diversity can help reduce disease and pest pressures by breaking up disease and pest cycles. Crop rotation can help with nutrient management as well. Legumes can be used in the rotation to decrease or eliminate nitrogen inputs in the year of planting and to decrease nitrogen needed in the next crop year.
The peas will they have the best rotational benefit. They put the most nitrogen into the soil.
Crops that are planted and harvested at different times, crops that have different rooting depths, and crops that are different types are just a few options, each with different benefits. For example, plants that have a longer rooting system can scavenge nitrogen from deeper areas of the soil profile.
I grew safflower because of its deep rooting, and that opens a way for nutrients to come up.
Other benefits of diverse crop rotations include spreading the production risk, such as weather and market conditions, and spreading the workload, such as having crops with different planting and harvesting dates. In other words, diverse crop rotations are designed so that the crops complement each other. Crop rotations are a well-established conservation practice in many parts of Montana. If you have been practicing no-till, you are already benefiting soil water holding capacity in several ways. Because you are not breaking up the structure of the soil each year with tillage, the soil pores remain intact and are able to improve water infiltration into the soil and maintain soil water holding capacity. You also avoid exposing the moist soil to surface conditions that dry out water you already had in the soil. Adding various crops and keeping the ground covered will add more organic matter and therefore increase the maximum moisture capacity of your soil. When designing a crop rotation, you want to be careful you are keeping the intensity of the rotation in the forefront of your mind. Match the water use intensity of your crop rotation to the native range surrounding you. A second concern with transitioning to continuous cropping is crop insurance and the implications changing your system may have for that. The carbon to nitrogen ratio on the surface and in the soil is important during the entire crop rotation. The carbon to nitrogen ratio is the ratio of the amount of carbon per the amount of nitrogen.
The carbon to nitrogen ratio is important because it helps to control the availability of the nitrogen that's in the soil. Microorganisms in the soil use the nitrogen as fuel to break down the carbon in the plant residues.
What this means to you, the farmer, is that the carbon to nitrogen ratio controls how well and how much of the nitrogen in the soil is available to your crop. If the carbon to nitrogen ratio is too high, soil organisms won't be able to break down high carbon surface residue, such as wheat straw, due to the lack of nitrogen. Therefore, the nitrogen needed for decomposition will be taken from the soil and the fertilizer that you applied. The typical carbon to nitrogen ratio in wheat straw is about 80:1. Compare that to pea residue, for which the ratio is about 30:1. Anyone that has grown a legume like peas and a high residue crop like wheat has observed that pea residue disappears much more quickly than wheat straw. This happens because of the difference in the carbon to nitrogen ratio between wheat and peas. The pea residue, because of the lower carbon to nitrogen ratio, is easier for the soil microorganisms to decompose. The carbon to nitrogen ratio in soil is usually about 24:1. It is this low due to the nitrogen in the organic matter in the soil, as well as the nitrogen within the living organisms in the soil. A well-balanced soil microbial population will have a carbon to nitrogen ratio of about 8:1. Cow manure with a ratio of 18:1, and pine sawdust with a ratio of 225:1. Planting peas or other legumes in a crop rotation after high-carbon crops such as wheat is an efficient and effective way to lower the carbon to nitrogen ratio and help break down residue more quickly.